watching this video is to review all the fraction information that you've learned in any past math classes and to make sure you understand everything I'm talking about, because we are going to move on to harder things with fractions and fractions involving negatives. So I want to make sure you have all this background. If you need to pause and rewind and listen again to really understand, please do that. Okay, so we're going to start at the very basics. Every fraction has a numerator, that is the top number. And every fraction has a denominator, that is the bottom number. The denominator tells you how many equal parts something is divided into. So if we are talking a cheesecake from Norske Nook, all right, that means it's divided into 4 equal parts. And I, unfortunately, only get to eat one of them in this fraction, 1/4. 1/4 is a proper fraction because the top number is smaller than the bottom number. The numerator is smaller than the denominator. All right, this is a mixed number. A mixed number has 2 parts. It has a whole number. That tells me how many whole cheesecakes I get to myself. And it has a fraction. So every whole number, or every mixed number, has a whole number part and a fraction part. The fraction part tells me I get an additional 1/4 of a cheesecake. Remember that mixed numbers can also be written as improper fractions. So instead of telling you that I get 1 1/4 of a cheesecake, I could tell you that I get my whole cheesecake and 1/4 of another, right? And I could cut this one into 4 pieces, and I could say, okay, that's 1, 2, 3, 4 fourths plus another 4th, so that's 5 fourths. 1 1/4, the mixed number 1 1/4, is the same as the improper fraction 5 fourths. A shortcut to do that would be to take your whole number times the denominator, 1 times 4, and then add the numerator. 1 times 4 is 4, plus 1 is 5 fourths. Okay, adding fractions, common sense. All right, I have my cheesecake. I get 2/4 of it, and I get 1/4 of another cheesecake. Do I get 3/8? No, 3/8 would mean I would get 3 of those little tiny pieces. No way, don't give me 3/8. All right, 2/4 plus 1/4 means I get 3/4 altogether. All right, so we kept our denominator the same, we added our numerators. All right, over here, here's my cheesecake. I get 2/4 according to our first fraction. All right, and then some horrible person comes along and says, nope, I'm taking one of those away. So this unnamed horrible person takes 1 of my pieces of cheesecake away, and I'm left with 1/4. Again, we kept our denominator and we subtracted this time our numerators. Okay, mixed numbers. I have 6 2/4 cheesecakes, but plus 1 whole cheesecake and another 4th. All right, so in this case, I have 7 cheesecakes and 3/4 of another. Life is good. This is like my dream. All right, now we'll go 6 2/4 minus 1 1/4. First, check the numerators of your fractions. Can we take 2 minus 1? Yes. 2 minus 1 is 1. Keep our denominator of 4. Now let's subtract the whole number part. 6 minus 1, which is 5. All right, now things get a little bit more complicated because we're subtracting, and the first thing I'm going to do is check that I can subtract my numerator. 1 minus 2. I don't want to deal with negatives yet in fractions, so we're not going to do 1 minus 2. There's another way we can do this. I need this number to be bigger. So what I'm going to do is I'm going to take one of these cheesecakes, one of these 6 beautiful, amazing cherry cheesecakes, or blueberry cheesecakes. Or maybe they're blueberry cheesecake ice cream cones from Ed's. Those are almost as good. All right? So I'm going to take one of these cheesecakes. And remember, they're all cut into 4 pieces. I'm going to take one of those. There it is. My whole cheesecake, every single slice is there. All right? So now I only have 5 cheesecakes. 5 whole cheesecakes, because I'm going to take this cheesecake, and instead of showing it as part of this whole number, I'm going to show it over here. So I have 1, 2, 3, 4 whole extra pieces to add on up here. So 4 plus 1 is 5. So now, instead of saying I have 6 1/4 cheesecake, I'm going to say I have 5 5/4 cheesecake, which means the exact same amount of cheesecake. I did not get rid of any cheesecake there. I wouldn't let that happen, okay? So this, right here, 5 5/4 is equivalent to 6 1/4. It's just another way of writing it. All right, so I have 5 5/4 cheesecakes minus 1 2/4. Some disastrous person stole my cheesecake. 1 2/4 of it. So now again, I can look at my numerators. 5 minus 2 is 3. Keep my denominator of 4. And subtract my whole numbers. 5 minus 1 is 4. So I have 4 3/4 cheesecakes, which is, not ideal, but it's still a decent amount of cheesecake. Okay, simplifying fractions. Some of you have called this reducing fractions in the past, and the reason I don't like reducing is because it makes it sound like it's getting smaller. It's not actually, nothing's getting smaller, nothing's disappearing. 2/4, here's my cheesecake. 2/4, all right? I can write an equivalent fraction. I can simplify that fraction to 1/2. Because as you'll notice, 2/4 of a cheesecake is also half of a cheesecake. I didn't reduce anything. I didn't lose any cheesecake. Heaven forbid that should happen, all right? I did not. I still have the exact same amount, so I just wrote 2/4 in a different way. I found another way to write it. The way you simplify fractions is you see if there is a factor of both the numerator and the denominator that I can divide out. So I noticed that my numerator and denominator can both be divided by 2. 2 divided by 2 is 1, 4 divided by 2 is 2, 2/4 is equivalent to 1/2, and 1/2 is in simplest form because I cannot divide both of these numbers by anything. All right, let's move on to this whole number. Okay, I can also simplify 3 2/4 to 3 1/2. 3 2/4 cheesecakes is the same as 3 whole cheesecakes plus a half of another. 11/4. Okay, I can't divide both of these by anything. 2 doesn't go into them both. 3 doesn't work. I can't divide them both by 4. So that won't work. I can write it as a mixed number. So I could say, okay, 11/4 of cheesecake. So there are 4/4. There are 8/4. 9, 10, 11/4. So I could write this as 2 full cheesecakes and 3/4 of another. So again, 11/4 is not different than 2 3/4, except that it looks different. It means the same amount of cheesecake. 11/4 is the improper fraction. 2 3/4 is its related mixed number. Okay, now we get into the good stuff. The reason that I have almost hated fractions my entire life, okay? Because it gets complicated, it gets messy, all right? If I have the problem, find 1/3 plus 1/5. That means that looks like this. Here's my cheesecake, cut into 3 pieces. They should be equal, but my drawing is about the only thing about me that's sometimes not perfect, all right? The other cheesecake, 4, 5, is cut into 5 pieces. So if you would say this, so I have 1/3 of that cheesecake, and I have 1/5 of that cheesecake. So if you were to say that the answer to this problem is 2/8, all right, that would be incorrect. Yes, I have 2 pieces of cheesecake, but they are not each 1/8 of a cheesecake, all right? This piece is not the same size as this piece. 1/3 is much bigger than 1/5, okay? And 2/8, people, that's like this, all right? So this plus this does not equal that, but you're telling me it does if you think the answer is 2/8, okay? So we need to make these fractions speak the same language. We need to have them have the same denominator. So what I'm going to do is I'm going to multiply my denominator by the other denominator to make an equivalent fraction. So here we took 1/3, and we're multiplying it by the other denominator, so 3 times 5. Okay, and when we do that, we get 5. 1 times 5 is 5, 3 times 5 is 15. 5/15. So 5/15 is the exact same amount of cheesecake as 1/3. If we go to our other one, 1/5. All right, we multiply the 5 by the other denominator of 3. And if we multiply a denominator denominator of 5 by 3, I must also do the numerator. So 1 times 3 is 3, 5 times 3 is 15. So now we get 5 fifteenths plus 3 fifteenths. And here we can follow the rules when we add of keeping our denominator and adding our numerator together. So we end up with 8 fifteenths. All right, or a little bit more than half the cheesecake. Subtracting, we do the exact same thing. All right, so here they said, okay, our denominators are different. That's a problem. When you add and subtract, you always have to select the same denominators. Okay, so we need a same denominator, common denominator, when we add or subtract fractions, always, always, always. All right, so here we multiply the 4 by 9, but if you do something to the denominator of a fraction, you always have to do the same thing to the numerator. As long as you do the same thing to each, you will never mess it up. All right, so 1/4 becomes 9/36. Okay, 9/36 means the exact same amount of cheesecake as 1/4 does. Okay, and then over here we took this denominator times the other denominator, 9 times 4, but if you do something to the denominator, you have to do it to the numerator. Always, always, always in fraction land. All right, so then we get 8/36. You can subtract the numerators, keep the denominator, and you get 1/36. Oh, okay. Go back here. All right, I know this video got long, but think of it this way. You have learned about fractions over many, many years and in many, many math classes and lessons, and we just condensed it down into about 12 minutes. All right, if there are things you still don't understand, please ask me, because you will need this information when we start applying negatives to fractions, and it really becomes 7th grade and pre-algebra math material. So, for class, as your proof of watching, please submit on Edmodo your number 1 through 10. All right, 1 through 10. 10, I get this, Ms. Hersher, fractions, love them, easy peasy. All right, or 1, oh my gosh, fractions, like what's the numerator again? All right, or somewhere in between. So please submit on Edmodo a number that tells me how you feel about what we just talked about in the video.